Hello, our lesson objective today we're looking at is 5.3G. Solve for quotients of decimals to hundredths, up to 4-digit dividends, and 2-digit whole number divisors, using strategies and algorithms, including the standard algorithm. So let's begin by looking at this example. We got 49.2 divided by 4. Well, we could rethink this problem. Instead of doing 49.2 divided by 4, what if we did 492 divided by 40? Okay, so let's see here. What are we doing when we change the 49.2 to 492? Well, we're making a number that's 10 times greater than what we had originally, right? So to keep the problem the same and not alter the problem, we would need to change the divisor to make it 10 times greater. So 4 times 10 is 40. That's where the 40 comes from. Now, instead of having to do a division problem involving decimals, we're just doing a basic division problem involving whole numbers. So this is just one strategy that we can use to eliminate decimals and to allow us to just be doing division with whole numbers. Okay? Alright, so here's another one. We got 2,574 divided by 60. Okay, if we're using the place value method for doing long division, it would look something like this. You got 60 goes into 2,574 40 times. Okay, so we're basically saying 40 times 60 gets us to 2,400. And then we're going to take the difference and look at what's left, and then we're going to divide it again. So when we take the difference, we're left with 174. So now the question is, how many times can 60 go in 174? Well, it could go in there another 2 times at least, right? Because 2 times 60 is 120. So let's remove 120 from the 174 we have left. And so that leaves us with 54 left. And so now we're thinking, okay, can 60 go into 54? No, not really. So 54 is our remainder. It's what's left over. So one of our options for what we can do with our remainder is we can take our remainder and put it over our divisor, which was 60, to make a fraction 54/60ths. Okay, because there's not enough left to make the full 60. So that's our part of our whole that's left, 54/60ths. So the combination of these makes our quotient. We do 40 plus 2 is 42. So that makes 42 and 54/60ths, which could be simplified because both 54 and 60 are divisible by 9. No, I'm sorry, they're both divisible by 6. And so we can divide 54 by 6 to get 9, and 60 divided by 6 gives us 10. So this can be simplified to 42 and 9/10. Okay, this is similar to the partial product method we used in multiplication. You're just basically breaking the number down by parts. So you're dividing 60, like I said, start out with here 40 times to get rid of 2,400 of it. Then we took what's left and we said, okay, how many more 60s can we take out of that? We take another 2 out of that. All right, so when you do it using this method, it could string out several steps until you do finally reduce it down to something that's less than your divisor. As long as at the end you add all your parts together, it doesn't matter. So even if I had started with 20 instead of 40 here, and then did another 20 over here, and then did another 2, that would have been fine, because when you total it together, you still get 42 when you're done. Okay, so this is using what we call the distributive method of division, but basically you're just dividing in parts until you get down to something less than the divisor. Okay, this is more of the standard algorithm that you guys are probably used to. So same exact problem we just did, but with this one we're saying, okay, 60 can't divide into 2, and sometimes when I do this I actually put a 0 here just so I remember I tried to divide 60 into 2, but that didn't work. 60 can't divide into 25 either, so we can put a 0 there to remind us that, nope, can't do that. All right, but 60 can go into 257 4 times. And so 60 goes into 257 4 times. Well, 4 times 60 is 240. Okay, so normally you guys wouldn't have put this here, and most of the times when you're doing your standard algorithm, you would just had this part. So then you would have subtracted and said, okay, 257 minus 240 leaves me 17. From there, I bring down the 4, right? This is kind of what you're more used to. So we bring down the 4, and now we have 174 left that we need to divide 60 into. So then, using our standard algorithm, we'd say, okay, 60 can go into 174 2 times. So we write a 2 up here. And we'd say, okay, 60 times 2 is 120. And we'd subtract, leaving us with 54 left over. There's nothing else to bring down at this point. So if we need to continue on this problem, if we don't want to create a fraction out of the 54/60th, like we did before, instead we want to find the decimal value of this. Using our standard algorithm, we can actually add a decimal to the end of our dividend and put a 0 here, and that doesn't change the value of the dividend. It's still 2,574. By putting a 0.0 in there, we didn't change that, but it allows us to have something to bring down so that we can continue the division. So now when we bring that down, it's okay, how many times will 60 go into this 540? And we can say, oh, that's 9 times. Okay, just remember though, if you add the decimal does need to come up here into your quotient. Don't lose it here. Bring it up into your quotient. And so you're saying, really, how many times will 60 go into 540? It goes in there 9 times. And now there's no longer a remainder, so there's no reason to continue to add zeros to the end of my dividend. Okay, I can stop. I don't have any remainder left. So 42.9 is the decimal result of this division problem, whereas on the last example we did it with a fraction remainder, and it was 42 9/10. Okay, same value, just a little different way to look at the remainder. Okay, let's quickly go through some different examples of what to do with that remainder whenever you do a division problem. So this first example we're going to look at is called ignore the remainder. So here you have a problem that says a total of $641.20, including the tax, was used to purchase $14 blankets for a shelter. The question says how many blankets were purchased. So if we divide our total by the cost per blanket, we should be able to figure out the number of blankets purchased, right? Well, when you actually divide those, you come up with an answer of 45.8. Well, it doesn't make any sense that we purchased 0.8 of a blanket, right? So for this one, we would actually just ignore the 0.8. It's not a whole nother blanket. So we really could have only purchased 45 blankets if it was $14 a blanket that we were paying for each blanket, okay? We couldn't have purchased 46. There wouldn't have been enough money there to do 46. So we just get rid of the remainder and say it's 45. Alright, this one's called add 1 to the quotient. So here we got a debt of $241.30 is to be paid off in payments of $19. So you got a starting amount of debt, and you're going to keep paying $19 off till it's paid off. So the question is, how many payments will it take before it's all completely paid off? So you could sit there and subtract $19 until you had nothing left in the debt, or you can do division. So if we divide it, 241.3 divided by 19 tells us that it's going to take 12.7 payments. Well, the problem is when you submit a payment for a bill, you don't submit 0.7 of a payment. You just submit whole payments, right? Well, if we only send 12 payments in, that's not going to be enough. We're going to fall a little bit short of our $241.30. So that means we're going to have to submit a 13th payment to finish paying this thing off. Okay? So in that example, the remainder would actually round up to the next whole number, because it's going to take 13 payments to get this thing totally paid off. Okay, so that's adding 1 to the quotient. Now for this example, it's called remainder is written as a decimal. Okay, we kind of did this one, something like this a little earlier. It says the price of a new sofa is $335.70. The cost could be separated into equal monthly payments over 18 months. What amount would each payment be? So we're literally taking a total cost for the sofa and dividing it out into 18 equal payments. So for this one, it would benefit us to be exact, and since we're dealing with money, it makes more sense to get a decimal remainder than to get a fractional remainder. So if we divide 335.7 by 18, we get a value of 18.65. Now, had that come out to be something with 3 decimal places, I would have went ahead and rounded off to 2 decimal places because we are dealing with money, and since money comes in values of dollars and cents, you don't need anything beyond 2 decimal places, so you would round it off to 2 decimal places. In this case, it came out to be $18.65. Now, sometimes our remainder is our actual answer. It's the answer to the question. So here's an example of that. It says a group of 30 students ordered shirts for their class trip. The total bill for all the shirts was $192.60. The students only collected $6 for the shirts and forgot about the tax. How much more will each student need to pay in order to cover the tax? So this is kind of interesting. We know there's 30 students, right? And we know that the total bill was $192.60. So if we divide that, we know that each student should pay $6.42. Okay, but the problem is that they only paid $6 each. So each student's still going to need to pay another 42 cents to cover the tax for the shirt. So the remainder there was the 0.42 in that division problem, right? Your decimal represents your remainder. So our remainder was 0.42. So our remainder represents the tax in this problem. It's the amount that wasn't paid for with the original $6. Okay, so that's an example where the remainder is your answer. All right, this one, conversion of remainder into smaller units. Okay, it says a precious gem weighing 236.8 ounces was discovered and was to be cut in half to display in 2 different museums. What will be the weight of the gem that will be displayed in each museum in pounds and ounces? So to begin with, we have to understand that there are 16 ounces in a pound. Okay, so if we divide 236.8 ounces by 16, that would give us how many pounds this precious gem weighs. So if we divide that, we get 14.8. So the gem weighs 14 pounds and 12.8 ounces because if it really weighs 14.8 pounds, then we got to find out, well, it takes 16 ounces to make a pound, so 0.8 of 16 is what number? Okay, so 0.8 of 16, 8/10 of 16 basically, is 12.8. So it's going to be 14 pounds and 12.8 ounces is the weight of the gem. So you get that by just multiplying 16 times 0.8. That's where that comes from. So you get 12.8 ounces. Now, if each gem's getting half of that weight, you're going to divide that amount in half. So dividing 14 pounds in half is pretty easy. 14 divided by 2, 7 pounds. Dividing 12.8 ounces in half, again, cut that number in half, you get 6.4 ounces. So each museum is going to receive 7 pounds and 6.4 ounces of the gem material. Okay? It may have been easier for you to divide the 14.8 by 2 first and figured out that each one was going to get 7.4 pounds, and then find out what 0.4 of 16 is to find out how many ounces that is. Either way, you would come out with the same results, whichever way made more sense to you. All right, that concludes our presentation on division using the standard algorithm and the distributive algorithm. Thank you for your time.